In this video, I want to explain how thread signaling works in Java. Basically, Java's thread signaling features enable threads to send signals to each other, which can be used to coordinate the thread execution between the threads. The core Java thread signaling mechanisms are the wait, notify, and notifyAll methods found in the object class, which is the superclass of all classes in Java. In other words, all objects in Java have a wait, notify, and notifyAll method, which are inherited from the object class. When a thread calls the wait method on some object, the thread is paused until either interrupted or another thread calls the notify or notifyAll method on the same object. Calling wait and notify is illustrated in the code example here on the left. First, the example creates an object, and then it creates a thread, which is given a runnable here to execute as a lambda expression. And as you can see, then it synchronizes on the signal object created up here, and then it calls signal object wait. Further down here, you can see another thread is created, also with a runnable as a lambda expression here. And it is also synchronizing on the signal object, that signal object created up here, and then it calls signal object.notify. So what will happen is that this thread here will, once started, will call signal object wait, and then it will be paused until this second thread here calls signal object notify. One important thing to notice about the wait and notify methods is that you cannot call neither wait nor notify on any object unless you have the synchronization lock on that object. So the waiting thread up here needs to first synchronize on the signal object, because that is the object that this thread is calling wait on. And similarly, the notifying thread down here needs to synchronize on the signal object, because that is the object it is calling notify on down here. So you cannot call wait or notify without having the synchronized lock on that particular object. Another important thing to note is that once a thread calls wait on an object, it releases the synchronization lock on that object. And that means that while this waiting thread here is blocked or paused inside of the wait call here, it does not hold the synchronization lock on signal object anymore. And if it did not release the lock, then it would not be possible for another thread here to synchronize on the same object and enter this synchronized block here, because then thread 1 up here, while blocked inside of wait, would keep the synchronization locked on the signal object forever, right? But as I just explained, once a thread calls wait, it releases the synchronization lock on that object, and thus it is possible for other threads to enter into blocks synchronized on the same object. What is happening more precisely is this. Thread 1 enters a block synchronized on the signal object, that is what happens here, and then acquires the synchronization lock on signal object. Then thread 1 calls wait, and while doing so, or when doing so, is paused, and it also releases the synchronization lock on the signal object again. That is indicated here by the green bar. So now thread 2 is able to enter a synchronized block that is synchronized on signal object. That is what happens here. And then thread 2 calls notify, and calling notify will wake up one thread that has called wait on signal object. And then thread 2 exits the synchronized block here. Once it exits the synchronized block, it releases the synchronization lock on signal object, as illustrated by the green bar here. And then thread 1 is able to exit the wait method here and enter back into the synchronized block here. In order to be able to enter back into the synchronized block, no other thread can hold the synchronization lock on signal object at the same time. So if there is another thread that still holds this this synchronization lock on signal object, then it is not possible yet for the thread to exit the wait call, even if it has been awakened by a notify call. But in this case, there is no other thread that holds the synchronization lock, because the only other thread calling anything on signal object or synchronizing a signal object is thread 2. And thread 2 has released the synchronization lock by exiting this synchronized block down here. So thread 1 can then exit the wait method here and enter back into the synchronized block. And when doing so, it retakes the synchronization lock on the signal object. And then once thread 1 exits the synchronized block here, it again also releases the synchronization lock on the signal object. It is quite common to move part of this logic here, the synchronization and the calls to wait and notify, inside of its own class. And I've created a signal carrier class here that illustrates this. This signal carrier class here has a do wait method, a do notify method, and a do notify all method. And basically what they do is that they synchronize on this, which is the instance of signal carrier that do wait is called on. And then do wait here calls wait on this, which is then the same object as the block here is synchronized on. The do notify method here calls notify inside the synchronized block, and the do notify all method calls the notify all method on this. Using the signal carrier object then looks like this. Instead of creating an instance of an object, we create an instance of signal carrier here. Then we create a new thread here, and inside of the runnable that is passed to the thread, it calls do wait. So instead of calling wait directly, it just calls do wait. Notice how there's no synchronized block visible out here, because the synchronized block is now located inside of the do wait method. This makes the code out here that calls the signal carrier do wait and do notify all methods a little bit shorter and clearer, and also less error prone, because now you don't have to remember to synchronize on the do wait object anymore, on the signal carrier object anymore, because this is done automatically for you inside of these methods, right? And then, as you can see down here in the notifier thread, all it has to do is to call do notify on the signal carrier, and then it will have the same effect as in the first example we saw here, where we have the synchronized blocks out here also. So as you can see, the code gets a little bit shorter that way. Plus, once you have the wait and notify calls inside of its own class, inside of its own object, you can do some other things that I will show you in a moment. But first, let's try to run this example and see what happens. Now, look at this. First, thread 0 calls wait. These print system out print lines, they are coming from in here. That's why I have them. I have them only for debug purposes. They are not actually necessary in a real signal carrier class here, but they are nice to have for debug purposes. But I mean, in a real application, you wouldn't have them, right? So anyways, as you can see, first thread 0 calls wait, and that is happening inside of the do wait method. Then thread 1 is calling notify, and that is happening inside here of the do notify method. And then thread 1 exits the notify method. That is the method printed here, or the statement printed here. And then, as you can see, now all of a sudden thread 0 can exit the wait method, and that is the statement printed here. Now, there is one potential problem to look out for in this example, and that is we're not guaranteed in what sequence the waiter thread and the notifier thread here are executed. And that means that in some rare cases, the notifier thread might actually start up first and call do notify before the waiter thread has called do wait. And that means that once the waiter thread calls do wait, the signal, the notify signal from the do notify call down here from the other thread is lost. It's missing. And this is a problem that is also referred to as missed signals. So in other words, the signal from the notifier thread is missed by the waiter thread up here. Let me see if I can get the code here to actually show that problem. And in order to do that, I just switch the two threads around, so the notifier thread starts a little bit earlier in order to provoke this problem. Let's see what happens when we run it. As you can see, we now immediately get the problem that thread 1 here calls do notify. That's the notifier thread. Then it exits the synchronized block in here. So it prints this statement, and then the notify signal is now lost. So once you call notify, it will only wake whatever threads are already waiting inside of a wait call, but the call here will not be recorded anywhere. So once in this example here, you can see once the waiter thread here calls do wait, and then through that call calls wait, the notify signal here is lost, it's missing, and that's why it's called missed signals. And that is exactly the situation you can see here. Thread 1 called notify, and then it exits the block here, and then thread 0 is calling wait, and now it's waiting indefinitely because there is no other thread in this example here that calls notify, so it's just paused inside of the wait call in here indefinitely. And if you look down here, you can also see that the code is still running. This little green button here, a light here, is signaling that this code example is still running. One way to solve the missed signals problem is to change the signal carrier class so that it can record the notification signals inside of the class or inside of an object of that class. And that is what I have done here in this signal holder class. As you can see, it now has two flags. One is called signal raised and the other one is called is thread waiting. As you can see, the do notify method has been modified so that it checks if there is a thread waiting or not. And if there is no thread waiting, if is thread waiting is false, that means that calling notify will have no effect. The signal would just be lost. So we record the signal internally by raising the signal raised flag here to true, and then it calls notify. I mean, nothing will happen when it calls notify. We have just established that if there is no thread waiting, then nothing will happen here, but at least the signal gets recorded internally, right? The do wait method has also been modified. And what it does is that it first checks if this signal raised is true. And if it is, it simply sets signal raised to false and then returns. Because if signal raised is true, that means that some thread has called do notify up here and raised the signal to true because there was no thread waiting. So it raised the signal to true before any thread could call do wait down here, right? So in that case, we say, okay, somebody already sent a signal. We will just consume that signal and return immediately. If the signal has not been raised, then we will, whatever thread calls do wait, will set is thread waiting to true, and then it will call wait, which will pause the thread until some thread up here calls do notify. In that case, is thread waiting will not be false, it will be true. So this if statement will be skipped, and the thread calling do notify will skip directly to calling notify, and that will wake up this thread down here, which will then set the is thread waiting flag back to false, and then it will exit the synchronized block and exit the do wait method. This solution to the missed signals problem still has one big problem, and that is if a thread calls do notify more than once before a thread calls do wait, well, then there is no recording of how many times do notify was called, because the flag here is simply a boolean, so it's either called or it's either true or false. And in case do notify is called 2 times, well, then the second time it's called, signal raised is already true. And then when do wait is called here, we set the signal raised to false immediately, and thus the second call to do notify is lost. The solution to this problem is to change the signal holder into this class signal counter here that instead of simply having a Boolean for to hold the signal, it has an int which counts the signals. And then similarly, we have a counter for how many threads are waiting here. And then do notify here has been modified. So if there are 0 threads waiting, that means that calling notify would just result in lost signals, missed signals. So what it does is it simply increments the signals counter up here, and then it calls notify, and nothing will happen in that case. But if there is at least 1 or more threads waiting, it will just call notify directly without incrementing the signals counter here. And then in the do wait method here, we check if there are any signals already. If the signals counter is larger than 0, then we simply decrement the signals counter here and return immediately without waiting, because that means there was already a signal stored. So there's no reason to wait for the signal. It has already passed us. And if there is no signal here, then what do wait does instead is it increments the threads waiting counter, and then it calls wait, and then it decrements the threads waiting counter again. So once it is no longer waiting, right? And so incrementing the threads waiting counter is what will make the do notify method here skip this if call. The do wait method has also been modified. So now it decrements the number of signals here, and if the signals counter after decrementation is either 0 or larger than 0, that means that at least 1 or more signals were stored before this decrement call. And then in that case, it simply prints out that there was already signals plus 1 signals stored, and so it's exiting without waiting, and that is done by simply calling or executing this return statement. However, if signals was 0 or less, then that means there were no signals stored yet. That means no call to do notify has been recorded yet. And in that case, it simply calls wait and waits until some thread calls do notify. Now is probably a good time to explain the difference between the notify and the notifyAll method. And I will just do that from or using this signal carrier class that I've shown you earlier in this video. So basically, it is possible for more than one thread to call wait on the same object, and in not exactly at the same time, because they still have to call wait from inside a synchronized block. So one at a time they can call wait, and then they become paused, and then they release the lock on, or the synchronization lock on the object that the synchronized block is synchronized on. If multiple threads are waiting on the same object, or have called wait on the same object, and are thus waiting for a notify call, what happens is that notify, if another thread calls notify on that same object, only one of these waiting threads will be awakened. Whereas if you call notifyAll, then all of the threads will be awakened from this one notifyAll call. Once they wake up, though, only one of the threads at a time can exit the wait method, because after all, to exit the wait method, they have to take the synchronization lock on this synchronization object. So one at a time they can exit the method, and then they exit this synchronized block, and then the next thread can exit the wait method, and then exit the synchronized block, etc., until all of the threads have exited the wait method. That is the only major difference between the notifyAll and the notify methods, that notify awakens only a single waiting thread, whereas notifyAll awakens all waiting threads. And while that seems like a subtle difference on the surface, it actually can have some quite different effects on your application's behavior, whether you're using a notify or a notifyAll call. The last thing I want to talk about in this video is the phenomenon of spurious wakeups. A spurious wake-up means a thread that wakes up after calling wait without any other thread having called notify or notifyAll, and that is the situation that I have illustrated here. So a thread calls wait, and for some reason some reason internally in the Java virtual machine, something happens and the thread then wakes up and exits wait without any other thread having called notify or notifyAll. I believe that spurious wakeups are caused by some kind of bug in the Java virtual machine, but it seems that this problem still exists. So because it exists in the virtual machine, we have to learn how to handle it. So let's have a look at a code example of how we can handle spurious wakeups. So if you look at this spurious wakeup signal guard class here, it has a monitor object and it has a flag saying whether this guard here was actually signaled by another thread or not. And as you can see, what happens here in the doNotify method is that we set was signal to true, and then we call notify on this monitor object up here. This is all kind of known stuff. We have seen this kind of construct before. What is new is down here in the doWait method. As you can see, there is now a while loop around the call to the monitor object's wait method. And that means that as long as was signaled here is false, then this while loop will keep repeating. And that means that, let's say that a thread calls doWait was signaled is false, so it calls wait. Then a spurious wakeup occurs, and the thread wakes up without any call to this doNotify method up here, and thus no call to this notify method here. So the thread that is waiting wakes up, but then it has to repeat the loop. It cannot just exit the loop, right? So it checks again and it sees, but there was no signal received. So it just calls wait again and then it waits. And so this kind of while loop around a wait call here is a common construct used to guard against spurious wakeups. And as you can see down here, in case it was signaled, then this while loop here will not repeat, because then was signaled is true, and then not true evaluates to false, and then the thread will continue down here. It will set was signal to false because now it is consuming that signal, and then it is exiting the synchronized block and then also exiting the doWait method. That is all for this video about thread signaling. Remember to check out the description below the video for links to a textual version of this tutorial as well as other related tutorials. And if you like this video, please hit the like button. And if you want to see more videos like this one, please subscribe to my channel.